All right. Welcome, everybody. Thank you so much for joining today. I'm going to let this awesome video play in the background for a minute or so while folks are joining, and then we're going to do a quick Acelab intro, show you how to get in touch with today's presenters on Acelab if you have any questions that come up after today's event, and then we'll go ahead and get started with the CEU approved course. All right, looks like we've got a good amount of folks here already. And I'm going to keep an eye out for my colleague, Helen. Sometimes she joins to say hello to everyone. Helen works really closely with the architects who use Acelab. So if you've come to a webinar before, you've probably met her. But if you haven't, I will launch oh, there she is. Perfect. I was just talking about you, Helen. Thanks for joining.
Hi, so sorry.
All good. Awesome. Well, then I would love to pass it over to you, Helen, whenever you're ready. Dean, if you wouldn't mind, there we go. Thank you. Yeah, so Helen will give a quick little Acelab intro, then we'll go ahead and get started with the CEU approved event.
Hi, everyone. How are you doing today? I'm Helen. I am the Director of Architect Experience here at Acelab. My job is to make sure that y'all have a great experience on the platform. So a few things today. First and foremost is that when y'all finish up this webinar, myself and my teammate Evelyn will be sending, basically setting up projects and connections for you to chat with Dean and the other Gladiator folks. And so keep an eye out for that. It'll show up as and something in your email, but also you can log back in to your Acelab account here. And then over here in Workspace under Conversations, you'll be able to go there and message. So that's how we're going to do the follow-ups for product literature, technical literature, samples, anything like that. And we're here to help. So please use that. You can also always use the live chat to reach out to us as well about any questions you might have or wanting to get connected with anybody, including the Gladiator folks. One other way you can do that is here at the top in the search bar, you can type in their name here, and then make sure you have brand selected. You'll be able to jump to their page, and here you'll be able to contact them directly when you hit this button. That'll also start a conversation, and then you'll also be able to see all of their different products that they have available to save into your projects. So last little thing I'll say is that we have a lot of exciting functionality coming out in the coming months, including the ability for y'all to generate schedules, and then kind of also the beginnings of a 3-part spec with our software. So if you want to kind of get ahead of that, I would recommend setting up a 15-minute call with me. We can talk about your firm and like your firm's needs. But essentially what we can do then is that we can build out something like, let me clear this out really quickly. Oops, sorry, I've got all of my screens right there. Something like this, for example, this is a sustainability library. So everyone at your firm could have access to this. You save all of your frequently used products that hit certain sustainability outcomes for you. One other quick little example down here is that we have an overall firm library. So research shows about 73% of products used on one project are used on the next. This is a way for your entire firm to have access to see what those products are and be able to kind of use them easily in their various projects. So for example, hey, I don't always need bird-friendly glass, but when I do, this is kind of our top choice as a firm, tested and you know, kind of tried and true. So just some examples of what you can do is Acelab. I hope you'll have a good presentation today. Thanks for letting me join.
Awesome. Thank you so much, Helen.
Bye.
All right. Yeah, feel free to fill out that poll if you are interested in setting up a demo with Helen. Definitely a great idea to get ahead of some of the really exciting new features that we're going to be launching. And I believe she'll also be dropping her meeting link in the chat. So if you want to just set up a time at your convenience, feel free to do that as well. All right, a few housekeeping items from me. I just want to encourage folks to please submit any questions to the Q&A throughout today's presentation. We'll have some time to discuss those during today's event at the end of our presentation. And then if we don't get to your question, we'll have a record of that so we can follow back up with you after today's webinar. Other than that, I just want to touch base about AIA credits. So we did ask for AIA numbers upon registration. We'll also send over a form in the chat momentarily where you can submit your AIA number as well as request a certificate. Those credits for AIA will be reported directly by the Gladiator team. So if you have any questions about that, reach out to Gladiator after today's event. All right. With that, I would love to pass it over to you, Dean, whenever you're ready to get started with today's presentation.
Perfect. Thank you very much. So it's great to be here and to do another presentation. So one unique thing about this presentation is as we go through it, on some of the slides, you'll see a QR code. And I'll usually tell you what that QR code leads to, but it's always going to be additional information on the content of the slide that we're looking at. And a little bit about me, a little bit about my background here, about 30 plus years of experience in the building envelope industry. So hopefully we can bring some of that to light as we go through the program. And a little bit about Gladiator up front before we get into the AIA portion of the presentation is the products and systems that you're going to see today are based on 30 to 35 years of installation experience of our parent company, which is Allied Specialty Group. And that experience is primarily in the New York City market, installing aluminum composite systems in the tri-state area. And the innovations really come from having systems that are faster, easier, and less expensive to install. The first one that we'll look at is the one on the left, which is the slotted Z. It's really an FRP Z-girt, thermally broken. You can see some of the features on the screen here. They come in sizes from 1.5 inches to 6 inches deep. And the big feature is it features onboard insulation securement. So whether it's mineral wool or rigid insulation, you have means to pretty much eliminate stick pins and use this peg and slot or rocket stick, as we call it, before we get into the AIA presentation. And alternatively, there's a clip and rail system, one that we see here on the right. Again, that's thermally broken. You see that with that purple thermoclip, and that's the thermal brake. There's also features an aluminum base track as well as an aluminum T-track and a termination piece as well. So all of that's aluminum, but thermally broken with the clip. Then, and each of those pieces comes in 10-foot lengths. So you're not dealing with a lot of small parts and pieces. It's really designed to, again, install quickly as a system. So with that, we will get into the AIA portion of the presentation. And as Bo had said, this course is approved for one AIA learning unit with health, safety, and welfare. And for those lead APs on the call, this also qualifies for one GBCI lead AP BD&C specific credit. And we will report the AIA and the GBCI credits on your behalf. So, and the way that you will know that that has happened, you'll receive an email from BNP Media. They're the ones that do the reporting for us. And then that email will have the opportunity for you to download a certificate as well. So whether you're AIA, GBCI, or none of the above, you'll still have the opportunity to have a certificate if you so desire. So the general disclaimers, we'll keep everything generic as we go through the program to qualify for that AIA credit. So it's important to note that how cladding is attached and supported from the exterior of the wall to the interior structure of the building is no longer just a question of transferring weight. And over the last 10 years, these cladding support systems have advanced to address the needs of modern buildings, to meet the new code requirements, and avoid the causes of issues inside the wall cavity as we learn more about how to select products that really work well together from both a performance and a constructability standpoint. And our learning objectives today, much of the program is going to revolve around resilience. So we'll be talking about resilience in the first part of the program, and then we'll talk about how we can enhance our resilience using rainscreen wall assemblies. And with those rainscreen assemblies, we'll be looking at ways of improving thermal efficiency. And we'll also take a look at attachments of various claddings so that we can improve our thermal performance and offer fewer penetrations of our WRB, or weather resistive barrier. So first off, if we want to talk about the QR code, this is going to talk about resilience and the building codes. And that's an article from Metal Construction News. And here's a definition of resilience as defined by the National Academies of Science, Engineering, and Medicine, as well as the USGBC. And sustainable building products and energy efficient systems can contribute to mitigation efforts like reducing greenhouse gas emissions. And hand in hand with mitigation is adaptation. So much of what we're going to talk about today is adaptation to weather and energy related events. And we'll also be discussing ways of improving building envelope performance. And most appropriately here, we'll be focusing on number one, reducing and preventing, and number two, prepare. But also, when we talk about resilience, there's also responding to, weather-related events, for example, and then say restoring power or building functionality, and part of that is recovery as well. So this is the four-step process recommended by the USGBC for integrating climate adaptation strategies into the building design process. So as we see here, this four-step process includes understanding regional impacts, modifying performance goals, determining the range of effects on the local built environment, and then number four, selecting a combination of these strategies, which may also include no regret outcomes. So even if it's just for the sake of building better. And after completing that four-step process, it can be applied across 6 categories of building resilience strategies. And for the purpose of our program today, we'll be talking and focusing on the building envelope and heating and cooling of buildings. So this is the first of 3 pilot credits available in the resilience category. So this is pilot credit 98, and we would be looking at option number 1, which requires identifying the range of project temperature, precipitation, and degree day changes based on the project service life. And then option number 2 is emergency preparedness planning. And then the second resilience credit with 2 possible points is available for designing buildings to withstand reasonably expected natural disasters. So you could choose 2 hazards from the standard found in the previous credit, which include, among others, flooding, hurricanes, earthquakes, extreme heat, and winter storms. And there's a workbook available for pilot credit 98 and 99, available at usgbc.org. So let's take a look at threats to the energy grid. So first of all, we have cyber attacks and denial of service. And according to the Threat Intelligence Index report, North American energy companies are the most attacked industry. And then we have domestic terrorism, and that's attacks and suspicious activities at U.S. power stations, which reached a decade-long high with more than 100 reported incidents in the first 8 months of 2022, as reported by the U.S. Department of Energy. And then we have natural disasters like hurricanes, tornadoes, fires, and maybe surprisingly or not so surprisingly, electric vehicle charging. So a 2021 study by the U.S. Department of Energy showed that The increased electrification or replacement of fossil fuel use with electricity would account for a 38% increase in electricity demand by the year 2050. And electric vehicles will play a major role in this increased electrification. And you may have seen these statistics before, but it's possible to affect the thermal resiliency of commercial buildings through energy efficient construction detailing. And those tools to improve our thermal performance are in our hands today at a very reasonable cost. And one of those tools that we'll be exploring today would be thermally broken facade attachment systems. And building science has shown that by eliminating or improving thermal bridging, that has a real effect on building energy usage. And this QR code will take you to the Better Building Solution Center.energy.gov, and we may see them appear on a couple of other slides as well. So there's a lot of good information there if you're interested in learning more about that topic. And then the third of 3 pilot credits related to resiliency is pilot credit 100. And option number 1 is passive survivability. And that's worth 1 point with 3 separate paths. And then option 2 is to offer backup power generation for critical loads. And that's also worth 1 point. So passive survivability is where the indoor temperatures maintain safe temperatures for an extended period without relying on external energy supplies. And grid resilience is decreasing or eliminating power system failures during peak demand periods or during natural or man-made interruptions. And this QR code will take you to pretty extensive survivability metrics based on many areas of the country, as well as a cost-benefit analysis and lead criteria. So this one is energycodes.gov/energy resilience. So building envelope design is the most significant factor influencing passive habitability. So here we see the thermal resilience of a typical existing building compared to a code minimum building and a high performance building over a 1-week winter power outage. And we can see here that the high performance building is habitable for a week. So that's the one with the solid black line, compared to the typical existing building survivability, it's only 2 days. And then the code minimum building, the one there in the center, only adds an additional day over the typical existing building. So thermal autonomy and thermal resilience are interrelated, and the same characteristics that extend thermal autonomy also help achieve higher levels of thermal resilience. So we know that as new energy codes are created and adopted regionally, in some cases, local jurisdictions have a different adoption rates or specific requirements to add in. So where your project is located and when it is constructed is directly impacted by these ever-changing requirements. And we could see here that energy codes work in tandem with other model codes to increase resiliency. So while energy codes have primarily developed to enhance energy efficiency, which should be a resilience goal in and of itself, they are also an important contributor to individual and community resilience in other ways. And this link will take you to the International Code Council white paper discussing resilience. So we know that high performance rainscreen systems combined with continuous insulation and thermally broken cladding support systems can help achieve this LEED requirement for minimum energy performance. And the implementation of energy codes have provided a tangible trade-off in energy consumption in both commercial and residential construction. So we can see here that LEED 4.1, BD and C has upgraded to ASHRAE 90.1, the 2016 version, which still, as we'll see later, still falls behind many model energy codes across the country. And this QR code will take you to the U.S. Department of Energy Better Buildings website. So this was a pretty interesting chart. We could see here that 1970s was a pivot point for energy. Political actions following the Arab oil embargo and the Iranian Revolution shaped our energy landscape for decades. So those of us who were around then know that quite well. So this chart from the U.S. Department of Energy shows the estimated improvement in both residential and commercial energy codes over time. And we could see on the upper left here that we have a baseline energy consumption equal to 100 in 1975. So that's our baseline. And as we move down and to the right, following the ASHRAE 90.1 line in green, we could see that the first big improvement in the late 80s revealed our first largest drop in energy usage. And since then, we've gone from that baseline of 100 to about 45% normalized energy usage in commercial buildings. And this map, updated in June of 2023, indicates the effectiveness of the adopted energy codes by state against ASHRAE 90.1 2019. And then the states in white were not analyzed due to having their own statewide or localized code. So we could see here that places like California, Washington, Oregon, New York, Massachusetts tend to lead the energy efficient design movement. And something new, and this has just recently been updated as well, this map. So this is building performance standards, and this highlights the status of building performance standards, the adoption across state and local levels across the country. So jurisdictions are colored according to their building performance standards, adoption status, and the selected performance metrics. So whether it's emissions or energy. And we could see here that if we take a look at New York City, for example, we could see that they've adopted Local Law 97, or that's what they've named it. And it's one of the most ambitious plans for reducing emissions across the nation. Local Law 97 was included in the Climate Mobilization Act passed by the New York City Council in April of 2019. And that was part of the then New York City Mayor's Green New Deal. So under that groundbreaking law, most buildings over 25,000 square feet are required to meet energy efficient and greenhouse gas emission limits by 2024. So that's in effect this year, with stricter limits coming into effect in 2030. So the goal is to reduce the emissions produced by the city's largest buildings by 40% by 2030 and by 80% by the year 2050. And of course, this QR code, if you are so desired to explore that, will take you to the New York City nyc.gov site talking about Local Law 97. And in August of last year, California became the first state to set general code standards that require the reduction of embodied carbon emissions in the design and building process, applicable to both commercial buildings and to schools. So this new code will augment the 2022 California Green Building Standards Code, otherwise known as Title 24. And this new requirement goes into effect July 1st of this year. So we know that small details can have a large impact in solving some of the conditions that we just learned about. So now we'll check out rain screens and their effect on thermal performance. So first off, we'll talk about LEED, and we can get one possible point by doing the simple box energy modeling before completing SDs, and so that we can demonstrate how to reduce energy loads and accomplish sustainability goals. So for this integrative process point, you can choose any two of the following systems. So we have energy-related systems, water-related systems, assessment for resilience, social equity, and health and well-being. So for the purpose of our discussion today, we would be looking at energy-related systems as well as resilience. And for the for the possible 18 points under the optimized energy performance category, 3 options are available. And with the building envelope across those options generally accounting for 1 point. And you really need, this one's pretty extensive, so you really need to see the standard for detailed information. And high performance rain screens with thermally broken cladding support systems are a proven way to moderate building envelope temperature changes in both warm and cold climates. And this again would take us to this QR code would take us again to the Better Building Solution Center.energy.gov. And there's a lot of information at that site. You'll find webinars, there's a library, partnership opportunities, as well as case studies. So it's a pretty extensive site. So we know that ventilated facades utilize an outer cladding to create an air cavity between it and the insulation layer. And that gap is the key to enhanced sustainability. And rain screen walls create a space for drainage and ventilation within the wall. And that gap or that space requires a break of 3/16 of an inch or greater per ASTM E2925. So that prevents that 3/16 of an inch or 5 millimeter break is going to prevent capillary action for drawing moisture from the back of the cladding to reach or from reaching the insulation or that WRB. And the space will also permit water drainage and allows for some air movement behind the cladding. And small details can have a large impact in solving some of the conditions that we just learned about. So let's take a look at the control layers of rain screen cladding systems. So a simplified definition of a rain screen consists of an exterior wall, an inner layer, and a cavity in between. So climate, cladding material, building codes combined with these inner layer materials like cladding supports, of which we're talking about today, insulation, air, water, and vapor barriers. All of a sudden, this simple rain screen can become very complex. So done correctly, the resulting assembly can be a very high-performing wall system. And this QR code will take you to the RAINA website, which is the Rain Screen Association in North America, of which we are a founding member. So let's take a look at these control layers. And these are listed in the order of importance with credit to Dr. Joe Stiebrick. And Dr. Stiebrick says, if you can't keep the rain out, don't waste your time on air. And if you can't keep the air out, then don't waste your time on the vapor. So the best place for these layers is on the outside of the building structure. And the cladding will function as an ultraviolet screen, as well as the initial water shedding element. And this is a diagram of a perfect wall. And this is credit to Dr. John Straub, another building scientist. So you can see all the layers listed here. But one thing is important to note that the perfect wall, as shown here, it's just a conceptual design aid. So it's going to identify the most important control layers arranged in such a manner as to result in a durable, functional enclosure that works in many climates and applications. However, the caveat is it's not the perfect arrangement for all materials, all applications, etc. And we should also note that some or all of these control layers are often found combined into a single product. So you can dig deeper into this. This QR code will take you to the Building Science Corp website. So it's buildingscience.com, and there is a lot of information on rainscreen science at that website. So the rain control layer simply needs to keep the water out of the building. And the rain control layer addresses the majority of rainscreen water management. And as Dr. Stieberg said in a couple of previous slides ago, he said, don't worry about air if you can't keep the water out. And then the air gap, that's the cavity in the rain screen definition that we provided earlier that prevents capillary action and moisture bridging, as well as promoting ventilation and drainage of moisture. So the cavity depth is large enough for drainage by gravity and for the exchange of air for passive drying. So we always note that the cladding is really going to dictate the amount of airspace that you have behind it. So water absorbent materials like brick, concrete, terracotta are typically going to require a larger gap, one that's going to prevent ventilation to move air through the cavity. And then we have the air control layer here shown in orange. And that air control layer has several requirements. So mainly that it is continuous and that it has the structural ability to withstand the construction process, as well as being durable enough to last for the life of the building. And depending on your climate, this may also act as your weather resistive barrier as well. And then we have a vapor control layer. And that vapor control layer can sometimes also act as the water resistant barrier. And this layer may be made of permeable, semi-permeable, temperature permeable, or non-permeable materials, the choice of which is going to be dictated by the climate and the wall design. And by ensuring proper installation and maintenance of the air barrier, the WRB, and the insulation, we can maximize energy efficiency, prevent water damage, and enhance the overall occupant comfort and satisfaction, which would also be applicable to well and lead interiors. And continuous insulation is going to play a very important role in not only meeting prescriptive R values, but also the alternative U factor calculated code compliance. So it's important to note in particular that it's not continuous insulation if you short circuit the insulation performance with metal Z-girts as the cladding support layer. And we see here that this is in italics here, we have the code definition of continuous insulation, which is pretty brief and could be somewhat ambiguous when we talk about fasteners and size and location of service openings. So let's talk about thermal bridging and its effect on thermal performance. So we know that thermal bridging allows for heat transfer through materials with a high thermal conductivity. And as we reviewed earlier, thermal bridging leads to increased energy consumption and carbon emissions. Also has an adverse impact on thermal resilience and thermal autonomy that we looked at earlier in the program. So here we could see a visualization of two different types of support systems in plan view. So on the right is an example of a thermal bridge where you could see the blue area is a cold temperature on the exterior of the building. And that is around a steel clip and it's transferring heat from the inside of the building out. So that's really a good example of maybe traditional construction, which shows a thermal bridge, which is typically going to occur every 16 inches on center all around the building and from the ground floor up. On the left, we could see the example of a thermally isolated system where a more advanced cladding support system using a polyamide material, which has low thermal conductivity, and that's pretty much successfully reduced or eliminated the opportunity for heat loss. And the same principles are true whether you're in a southern climate where the temperatures are reversed with hot exteriors and air-conditioned interiors. And addressing thermal bridging is really crucial for improving energy efficiency, indoor comfort, and preventing moisture-related issues, one of which would be mold or rusting of our structure behind our cladding. So here are some effective strategies for mitigating thermal bridging, and those are listed here. We've reviewed continuous insulation, thermal breaks, improving our design, our insulation placement so that we can minimize thermal conductivity through our building materials, and then subscribing to advanced building codes, which will give us an improved thermal performance of our structure. So here are a couple of resources on the subject, one of which is the Morrison Hershfield Thermal Bridging Guide. And that contains over 600 assemblies which have been thermally modeled. And they include different wall systems and configurations, which would include clear wall, assembly joints, windows, doors, balconies, and roof assemblies. And this image here is a screenshot. It shows the parts, pieces, and thermal properties of our assembly. This image shows the thermal modeling results. And in this case, you can see in the chart below that they've modeled 2, 3, and 4 inches of mineral wool insulation. And you can see the effect and the actual effective R value of that assembled system. And we'll look at the difference between effective R value and nominal R value in a couple of slides. And then this is from the RDH website. So it too is really a treasure trove of information on building science topics. So they have white papers and presentations, and there's just a lot of information as we can see here. And then here's an example of what RDH modeled, showing the relative cost, the very poor performance, and constructability of vertical steel girts. So the theme of what we've been talking about, if nothing else, is that vertical steel girts aligned with your stud on the other side of the gypsum is really the worst possible choice you can make when you are designing a cladding support system. And you can see here in the top center of this particular slide that the thermal efficiency of a vertical Z-girt is going to be in the range of 20 to 40%. So it's about as low as you can go. So let's take a look at some other materials that you can use in your wall assemblies that will help improve thermal performance as well as sustainability topics. So under materials and resources, we have two possible points. And that allows for documentation options such as declare labels, EPDs, cradle to cradle, health product declarations, and more. So there's a lot there, so you need to see that standard for more details. And know that many manufacturers as well as material trade organizations have EPDs and LCAs available to help leverage those two possible points. And on this slide, we're showing that we have these materials that are commonly used as thermal breaks or in part of systems anyway, because we're talking about galvanized steel, stainless steel, and aluminum, not very good thermal breaks by themselves. And what we're talking about here is the recyclability of each of the materials listed. So we know that the first three, we could take those materials and we could take them down to the local scrap yard, recycle them, and walk out with a check. The more thermally effective materials, fiberglass, polyamide, and polycarbonate, all of those are very much recyclable, but they are really more proprietary processes that we just don't see those on the recycling of those on every on the corner of every town. So let's talk about how we can improve thermal performance of wall systems. And to do that, we could look at the differences of materials commonly used in the wall assembly other than insulation. So we saw those materials that have a high thermal resistance, and those are listed here on the top. So we have the fiberglass, polyamide, and other plastics, and then the materials with low thermal resilience or a high thermal conductivity are listed below in blue. So effective solutions for the elimination of thermal bridging to minimize heat transfer include thermal breaks, continuous insulation, and improved building design. And thermally broken wall assemblies are really decidedly effective for achieving high effective R values and the resulting thermal comfort. And several strategies of minimizing enclosure heat flow are listed here. But the one that we're going to concentrate on today will be continuous thermal insulation with minimal thermal bridging so that we can achieve high effective R values. So this chart pretty much tells the story. And if we just briefly look at the gist of the chart, is we could see that we are evaluating 2, 3, and 4 inches of mineral wool insulation, and you can see their nominal R values right next to that in the second column. So that's the nominal R value of the insulation itself. Now, if you make an assembly with those vertical, in this case, stainless steel girts, 16 inches on center, we see that we have a reduction in our effective R values. So in the case of 2 inches, we've gone from an 8.4 to a 7.8. If we double our insulation thickness, we can double our nominal R value to a 16.8, but we just barely limp over and get a 10.3 with our effective R value. So we could see that by doubling the insulation when we're using in this case, stainless steel girts, vertically 16 inches on center, it's a very poor performing wall assembly. We can improve that a little bit if we go to that fourth column and we use those girts horizontally. So now we can improve our R value from that nominal R value of a 8.4 up to an 8.7. And the reason it went up is we have they've evaluated the entire wall assembly. So we have air films and other materials in that wall assembly that help contribute to the additional R value. But again, doubling the R value or doubling the thickness of the insulation is not going to double your R value. Now, let's compare and contrast to a clip and rail system where we have vertical rails 16 inches on center with clips spaced vertically 24 inches on center. Now we can see that we at 2 inches of thickness, we've gone from an 8.4 to a 9.1. And if we double the insulation thickness, we actually almost double the R value. We go from a 16.8 all the way up to a 17.6. So you can see that by using the proper materials, thermally broken materials, it really has a tangible effect on the actual R value of your wall systems. And here you can see a analysis done by the top section done by RDH Building Science, and the bottom section there, number 2, done by Morrison Hirschfield. And you can see the relative performance of the different systems that are available to you on the market today. These are choices that you can make, and you can see the resulting performance. So this just gives you an idea of how easily you can improve the thermal performance of a wall system. And a closer look here, we can see that we have insulation, how that's encapsulating the clips that we see here on the left. So we see the insulation going around those low thermal conductivity clips to give you that high effective thermal performance. And you could also notice that some of these systems do not require stick pins for insulation securement. So the result is that you have many fewer penetrations to your weather resistive barrier. And then another couple of systems, these are also available on the market as cladding support systems. So knowing that, generally speaking, cladding support systems that use materials with low thermal conductivity are going to give you the best effective thermal performance. And then our last learning objective, as we kind of wrap things up here, is that you have these 2 different types of cladding support systems available. So we have these Z-girts or hat channels that we see on this slide. And then we have clip and rail systems, which we'll see in the next. So, and you can see really the evolution from left to right as we've gone from, utilizing the old legacy steel and stainless steel Z-girts to these more highly improved systems that you see here on this slide. And then alternatively, we have these clip and rail systems. Again, starting off years ago where you maybe would have had just a brake press metal that you would create some sort of a attachment system with, and now you have these more sophisticated thermally broken systems that we see here. So this is what we often see on bid day. And it leaves a lot open to interpretation of how the cladding is going to be supported. So we could take a look at some of those options here on this slide. We can see that without a more defined direction, there's multiple ways in which we can support our exterior cladding. And we see those listed here. So we can We've looked at the vertical Z-gird and the performance of the horizontal Z-girds. We can do crossing Zs. There's a variety of ways that we can go about it. And you can see that there are pitfalls in many of these different options. So pressing forward, we could see that we could further demonstrate that the panels are never going to match the layout of your support structure. So we know that our studs are going to be 16 or 24 inches on center, but our cladding and the cladding supports are going to be a different story. So you can see the option here on the left is we have an area where we need an additional support. So to solve that, the contractor or the architect has drawn in an additional support, and you see that that additional support is going to cause additional labor, additional materials, and it's really going to make the job of installing the insulation a bit more difficult. And then the picture in the middle, we see that we could solve that a little more easily by adding that vertical hat channel over those horizontal Z-girts. The insulation then installs quite nicely, but we've now added thickness to the wall assembly. And that's not always an option, especially if we have maybe a zero lot line situation that we're designing to. So an option would be something that looks like this, where you could see that at number one, you have an attachment system that can be optionally included if you have an area that you need to attach your cladding to. And if you don't need it, you don't need it. So like we see over here in this bay, those horizontal flush mounted pieces are excluded. And then number two, we have these thermally broken connectors. So those are going to be engineered accordingly. So nothing really changes there when you're attaching your cladding. And we could see here an example of that system being used both horizontally and vertically. So these are what we might call as one manufacturer coplanar. And that coplanar is just everything in the same plane. And those coplanar systems are designed to fasten panels in the same plane and increase the number of attachment points without increasing the depth of the system or adding thermal bridging or additional penetrations to your air, water, vapor barriers. And we know that the cladding is going to dictate what you do with the cladding support system behind it. And some of those factors are listed here: the weight of the panel, the dimensions, the depth of your exterior cavity, if we're doing a rain screen or not, whether it falls under a pressure equalized rain screen or not, or perhaps maybe an open joint rain screen. And then the facade manufacturer requirements themselves. So each manufacturer is going to have their own requirements regarding elements like moisture and fire testing. So really, in conclusion, we looked at addressing thermal bridging. It's really essential for that resiliency topic and making energy efficient designs. And we looked at rain screen layers, putting them in the proper place, insulation strategies. We looked at considering the consideration of thermal bridging, and we talked about minimizing heat loss so that we can improve occupant comfort and reduce energy consumption. So that is the end of the AIA portion of the presentation. And if we've got a couple minutes, maybe questions, but you can find us obviously at Acelab. We're quite active on LinkedIn, RCAT, and certainly you can find us, those of you who subscribe to SpecLink. And for those of you who don't, we have CSI formatted 3-part specifications available as well. Thank you, Bo.
All right, awesome. So yeah, if anybody's got any questions, feel free to either submit it to the Q&A, or you can also raise your hand. I'll keep my eye out for that, and we can unmute you so that you can ask a question out loud. You don't have to turn your video on, so I promise it's not super scary. But if you have a longer-winded question or something, you know, that feels really specific, feel free to raise your hand and ask that out loud. All right, and we'll stay tuned for another minute or so to see if we have any questions. Looks like we didn't have any lined up, so you must have done a really great job explaining everything, Dean.
Hopefully.
All right, and then we've got a thank you, very informative. That's awesome. While we're here waiting for any other questions, I'll just do a really quick refresher for anybody who might have missed the first few minutes of today's webinar. Dean, would you mind if I take over screen share for a moment?
Absolutely.
Awesome. All right. So I just want to do a quick little tour of how to get in touch with these folks on Acelab if you do have any questions that come up after today's event. We'll also have the opportunity in the post-event survey to list any questions there as well. But this can be a great way to get in touch with the folks at Gladiator and many other manufacturers so that you can really keep all of your conversations with manufacturers organized by project and integrated with the rest of your building product research. So if you head over to Acelab, you can use this search bar at the top to search for brands, search for products. Sometimes you have to toggle between these to get to where you're going, but it'll generally cross search between these 3 categories. Can head over to Gladiator's page on Acelab, and you can click this contact button to get in touch directly with their team. You'll be asked a few questions about what type of information you're looking for, if it's project specific. And then to get back to that, you can head over to your workspace and go to your conversations, and this will be where all of your communication is saved. All right, and it looks like we did just have a question pop up, so I'm going to stop sharing there, but feel free to grab. There was a meeting link in the chat from Helen. If you want another quick demo, you can sign up for a 15-minute meeting there. All right, from Kat, can these cladding systems be used in high wind or coastal areas?
Yes, they can. They've been, at least in our case, as one manufacturer, tested to 60-pound live loads with the cladding alone. So really, the only difference would be the support spacing, perhaps, just depending on the wind pressures and the height of the building and the cladding material being used.
Awesome. All right, great. I am going to drop a link in the chat to get to Gladiator's page on Acelab. Just a reminder before we jump off for the day to grab any of the links from the chat that you might need. And for that AIA submission form, if you are planning on submitting your AIA number there, please do that as soon as possible. Before the end of the day would be great, because we do export that and try to get on that quickly.
And the GBCI folks as well.
Yes, and GBCI folks as well. And I think we might have only put a field there for AIA, but you can just put GBCI information there and specify that for us. All right, great. Looks like we've got a bunch of thank yous. Everybody's saying it was a very excellent, informative presentation. So that's super awesome. We love to hear that. If any questions come up, you know where to find Acelab, you know where to find the folks at Gladiator. So please feel free to reach out if you have any questions after today's event. And if you do have a moment as you leave today's webinar to fill out that post-event survey, that's super helpful for us to be able to continue bringing content that is relevant to you. All right, with that, looks like we're almost at time. So I just want to thank everyone so much for attending today. And thank you, Dean, for such an excellent presentation. We really appreciate having you here.
Yeah, thank you, everybody.
All right, have a great rest of your day.